Okay, we're just looking over the homework ahead of time for our lesson today, which is technically 15.2, solving day 2. Now, this is all about factoring, and these can't be factored as they are, but you can replace and do things off of the identity sheet, which I handed out in class just now to anybody who hadn't already got one. And this one can be replaced with something that has sign in it. Do you see it? Yes, sir. It's not just 1 minus sign. There you go. 1 minus 2 sine squared. 1 minus 2 sine squared theta. It's not just like, just look on the sheet. It's just on the sheet. You see it in the lower right hand corner? It's just a list on the sheet. It's not like you had to like be a genius. You just had to look it up. Although if you've got it memorized, that is pretty cool. All right, so now we can multiply this thing out 3 times the 1 and 3 times the negative 2 sine squared. And then we got to bring all this stuff over to the other side. It doesn't matter if you bring the stuff from the right to the left or from the left to the right, but it all needs to get onto one side. And then you'll set it equal to 0. Once you have the thing set equal to 0, you can factor it. Good question. I know you're gone yesterday, but I will remind you. Do you remember in higher algebra you learned how to take things like that and solve them and say, oh, so this equals 0 or that equals 0? And so it's the same idea, except now you're going to have like sine x plus 1 and sine x minus 3 or whatever. And you set this equal to 0 to find one of your answers, and set that equal to 0 to find your other answer. If you want a more thorough explanation, watch the video from yesterday. All right, so this page, skip the one on the left. You can skip number 25. And then that only leaves us with one more. And what's the secret on this one? Well, cosine to the third is strange. So you got to break it up into something you can actually find on your sheet, like what? Cosine squared times cosine. Then I would always try to get them factored and equal to 0. So easy once you got it that far, because then this part is set equal to 0, and that part's set equal to 0. You got 2 equations, you solve them both. So, that's the overview of what your homework assignments are about for today. But let's do some practice on some more strange ones. They're not going to be quite as simple as yesterday's. Okay, so tangent of the inverse sine of 0. That one is strange on a whole bunch of levels because you're not going to be able to draw a triangle for it. And when you're at a quadrantal, everything is different. I'm going to pause for a second and give that one a try. All right, so did you say that sine was only allowed, because this is inverse sine, it's only allowed over here and over here, so these have to be thrown out. You get what I just said there. That's really critical, that inverse sine has rules on where it can be. And its inverse sine is only allowed between here and here. Okay? Then, if it's in that zone, and it's going to be weird because it has a side of 0 and 1. That means you cannot make a triangle that has a side of 0. And therefore, I got to find where y is 0, because that's what sine is. Sine is y. Where is y 0? That spot, or that spot, because they're all legal. They're all allowed. Only this spot has y equal to 0. So you're at that spot, which means your answer for this part, weirdly, is 0, but it's a different 0. What do you mean a different 0? Because it's an angle of 0 instead of what you were originally given was the side was 0. Okay, so that's 0 degrees. So then the question becomes, what's tangent of 0 degrees or 0 radians? Either way, it's tangent at that spot. So what's tangent? Y over x. 0 over 1. Answer is 0. If you were thinking 0 over 1 was undefined, you were getting confused. It's 1 over 0 that would be undefined. Okay. That puts you through some mental gymnastics, but pretty simple answer. Yes? Good question. If you take that's a good question. It all depends on the actually, no, it doesn't. In this case, you're right, because it's an inverse, it wouldn't matter if they said all solutions or not. If it's an inverse, there is only one answer, always, on an inverse question. Okay, so, all right, moving on. Let's do a strange but simple. Strange because the answer is really complicated looking. But there's only one step before you're like already doing the answer, and then your answer is complicated because I'm going to say find all solutions. Okay, pause for a second. Let me give that a try. Okay, we're going to try another one that's a little strange. This one, you'll never figure out what the angle was, but yet you can figure out tangent of the angle. Now, even though some of you are probably thinking, is this that U substitution kind? No, it's not. I'll pause for a moment while you give that one a try. Okay, let's see if you figured this one out. Sine of some angle is x plus 1 over 1. First of all, I added that one so I could have two sides. Now, if you go through the all students take calc thing, you're actually going to be misleading yourself just a little bit, because you're going to try to figure out what two spots to maybe get this answer. You can't, because this is an inverse sine question, right? And so if it's an inverse sine question, you can't have more than one answer. And if there's only one answer, which should it be in? Well, where sine is positive would have to be here. So it can't be there. Now, you could argue that x could be negative, but you're going to just get yourself all confused. Just put it in this quadrant right here. So sine is opposite, hypotenuse, and then what is that side? That becomes the key to the whole question. It's the square root of 1 squared minus the other 1 squared. 1 squared, which is 1, minus x plus 1 quantity squared. Now, if you wanted to work that all out, you could say 1 minus x plus 1 times x plus 1. And you could do all of this. You don't have to. If you want to do that, I could live with it. I would have left it like that personally. But this would also been okay. Now, that is just a side of this triangle. So then, okay, yes. Okay, so I am subtracting x squared, and then I'm going to subtract 2x, and then I'm going to subtract 1. Oh, I see what you're saying. Yes, yes, it would be. But it doesn't matter. I'm sorry, it does matter. That matters. But the final answer is the tangent of this angle, which it doesn't matter what angle this is. It matters that we find the tangent of that angle. Tangent is TOA, opposite, over adjacent. And therefore, it's x plus 1 over square root of, and I'm just going to leave it like I had originally written it, 1 minus x plus 1 squared. Complicated, but correct. Who had it right? Raise your hand if you did. All right. Yes?
So you don't want to simplify all the way?
So I would have left it like this. Any other ones? Any other questions on this one? I know that stretched you, but if you knew that you needed to find the square root and it was just about the simplifying here, then don't stress because it won't be that complicated on the simplifying. So, all right. Then, let's talk a little bit more about factoring. Back when life was easy, we would have it all pre-factored for you. And then you could just answer this by saying, oh, -3 makes this part 0, so -3. And that part would be 5/2, 5/2. But it's really happening like this, and then you're solving it. And x plus 3 equals 0, and you're solving it. And so then, how can you get a trig equation to factor? Well, you can use a u substitution again if you want to, but it's up to you. All right, I'd like you to try this one, and something strange will happen. If you want to do a u substitution, you could let sine of x equal u, and then you'll have u squared plus 3u plus 2. A lot easier to factor because it doesn't have the signs running all over the place, and it would work. But if you'd rather just factor it directly with the signs, I'm good with that. Okay, so you should have found that it was y is -1 because you can't draw a triangle for that. So if y is -1, that's your spot because that's where y is -1. The point here is 0, -1. There we go. So it's 3 pi over 2 is your answer. And why is there no answer for that? What? We haven't done many of those, but why can't sine be -2? Yes. That's a good reason. It's opposite over hypotenuse, and all of a sudden the hypotenuse is really small. That's not possible. Yes. And here's another way to think of it. You get that sine goes, it's a wave, and it goes on forever like that, and that's the lowest it ever goes. -1. So it can't be -2. So you say, on this part, no solution. Now, does that mean that there's no solution to this whole thing? No. This is an answer. It's just that there's no extra answers coming from this. So 3 pi over 2 works because if you put a 3 pi over 2 right here and here, when you actually figure out the answer to all of that, it would equal 0, which is the point. All right, I know that's complicated, but I was trying to show you one where you have a no solution part of it. Let me give you another one that would have no solution. No, actually tangent can go forever, so let's go with cosine of theta equals, well, how about this? What is the range that could work? What's the lowest it goes? -1, so could we figure out an answer for that? Yeah. How about, does cosine ever equal 0? Yeah. What's the highest cosine could ever be? 1. So if you have any answer that's outside of that little zone between -1 and 1, then it's not possible. Okay, so let's say that it says cosine of theta equals 2. And I know what you're saying, but if I shifted it or stretched it, let's say I put a 2 there, to get really, I would divide both sides by 2, and all of a sudden it would be regular cosine equals 1, which is doable again. But that is not possible. So there's no solution. All right, just reminding you that there's sometimes scenarios in which there is no solution. Okay, here's last one that'll stretch you a little bit because it's backwards of what you've done over and over again, and we'll just see if you can handle thinking backwards. 5 pi over 6. I'll pause for a second while you give that one a shot. Okay, so where is 5 pi over 6? Well, here's 1 pi over 6. It's like a 30-degree angle, right? And then 2, 3, 4, 5 pi over 6. Oh, is that the problem? That is a 5 pi over 6. All right. I'm sorry, my handwriting was sloppy. I'll admit that. All right. So then, what is the sign right there? Well, I can make a little triangle since that's a pi over 6, and I can say that's across from a 1, and then this must be the 2, and the root 3, and this must be negative. And so then I can say inverse cosine of that. Whoa, it gets really confusing. Yeah, exactly. You need to know that that means I want an answer that's an angle. I want an angle for that. Okay. Here's another way to think of it. What is the sine of 5 pi over 6? Sine is opposite over hypotenuse, right? And so here's opposite, here's hypotenuse, so it's 1/2. So then the new problem becomes inverse cosine of 1/2. Now here's the thing. People think that on like all the other ones, you would just go, oh, so I got a triangle drawn. Let's do cosine on the triangle. Cosine is adjacent over hypotenuse, and it's that. No, we're not doing cosine on this. We're figuring out the angle that would work. All right, so is cosine even 1/2 in this triangle? Because if you rewrite this, you're saying I want cosine of some angle to equal 1/2. Is cosine even 1/2 in there? Do you even lift? No. No. Okay, so this, all students take cosine's positive in those two, and let's see, this is an inverse cosine question, so it can't be here, so I'm down to just this. Cosine is adjacent over hypotenuse. And finally, I have come to the angle that they really wanted, and the angle is pi over 3. All right, I'll pause for a second. Okay, next I'm going to show you a little quiz that'll help you see if you're on track. All right, I know we have a short amount of time, but I want to walk you through this. This is not to be graded. This is 2 questions to see if you're on track. Okay, so I know we have 3 minutes left, but the top one here is the U substitution kind. Do you get that we're going to let U equal 3x, and that becomes a U, and then all of a sudden I just got to find a couple answers, which really isn't that hard. Okay, so sine is negative because it says so right there. So it can't be here, can't be here, and I'd have 2 answers, and sine is opposite hypotenuse, opposite hypotenuse, and I would have, this is a pi over 3, so it's 4 pi over 3 and 5 pi over 3. But the problem is, you can't just stop with that because we did a U substitution. So we made the problem easier, now we got to make the problem harder because we got to take the U out and put back in the 3x. So this would be 3x, and this would be 3x. So what am I missing still, though? Plus 2 pi k. Don't forget that part. Then you can multiply everything by 1/3. Four pi over 9 plus 3 pi k over, no, 2 pi k over 3, and 5 pi over 9 plus 2 pi k over 3. All right, that'd be pretty intense. Now this one had a wicked twist in it because this plus 2 could be made into 1 plus 1, and then one of those 1s can be stolen away and put here. Why would I do all of that? Because that is equal to what? Sine squared. You recognize that 1 minus cosine squared is sine squared? Now, other kids that didn't notice that also said, well, can't you just replace cosine squared with 1 minus sine squared and just put it in like this? You absolutely can. Why are we doing all of that? So that your sine squared and your sine can all line up and you can factor this thing. And once it's factored, we just practice that before it's easy. All right. How many of you feel like you could have done those problems? All right. And if it's not the top one, then watch yesterday's because that's where I talked about how to do that kind a lot. Did like 3 practice problems on it. All right. So the actual test, that was it. I just had to summarize it for you. The actual test is coming on Tuesday. So, also note, we did not grade the Tide Lab today. That means we will be grading it on Monday. That's the plan anyway. That's all I got for you for today.